Hi guys, today's video is a couple things, writing linear equations using point slope form. We might be talking a little bit about standard form and also about scatter plots and linear regression. First, we have to know what the point slope formula is. Y minus y1 equals m parenthesis x minus x1, recap from algebra 1. So, real easy, number 1. Substituting in -1 for x1 and 7 in for y1, and this is your m, your slope. We can write our equation in point slope form as y minus y1 is 7 equals m is -4, parenthesis x minus x1, in this case x1 is a -1, so we're going to do minus a -1, which makes this a plus right here. Be careful with those opposite signs in the formula here and here. So this is point slope form. If we wanted to convert it to, let's say, standard or slope intercept, we would have to do some distribution and isolating the y on the left side. Let's move down and look at a different type of form. Here we have two ordered pairs, but no slope. We're going to write this actually in point slope formula again. So in order to write the equation in point slope formula, we're going to have to find the slope first. y1 minus y2 over x1 minus x2. That gives you the slope. And then we can write our point slope formula, which is the y minus y1 equaling the m x minus x1 like we have above. Doing number 3, to start out with, we're going to find the slope first. So m is going to equal. Now I'm going to label my x and my y's, x1, y1, x2, y2. It doesn't matter which one's the first or the second, but as long as they're consistent with each other. Let's move my m down a little bit. So my slope is going to be x1 minus start over for a second. Y's go on top, it's the change of the y, so y1 minus y2 over x1 minus x2. Be careful with that double negative right there. 1 minus 7 for the y's on top gives you -6. And then x1 minus x2 is -6 plus 3 gives you -3, simplifying the slope to give a +2. Now we can write our point slope formula as y minus y1. Here you can choose either ordered pair to put in for the x1 and y1. I'm just going to stick with this first one. So y minus y1 is 1, equaling m, we just found was 2, parenthesis x minus, and then x1 here is -6. So doing a negative makes a +6 there. That is my equation in point slope form. Let's do a couple application word problems, taking any real-life situation and writing in either point slope form or slope intercept. Number 7, a cab ride costs $4 plus $1.75 per mile driven. We're going to write an equation representing the cab fare to find the variables. So in this case, I'm going to have x and y as my variables. I'm going to have x representing the miles driven. That's my independent variable. And then y is what you're measuring. Y is the cost or the money. So now I can write my equation as the cost is going to equal $1.75 per mile. Whenever you see the per, that's usually the number is going to represent the slope or the m. And then you have the $4 is the flat fee. That's your y-intercept. In this case, we had slope-intercept form type of an equation. Then answering part B of this problem, if Clay's destination is 17 miles away and he has $30, will he make it? Plugging the 17 in for the miles, which is x, and the $30 in for y, we can solve. Is $30 going to equal $1.75 times the 17 plus 4? That is over $30, so no, Clay will not make the trip. Let's scroll down a little bit to the next page. We go a linear application word problem, writing in standard form, recapping what standard form is. We have ax plus by is going to equal our c. So number 10, Josh bought 3 bags of soil and 10 bags of mulch from Home Depot. Writing an equation to represent this situation and defining our variables. Let's let x be the number of bags of soil and then y being the number of bags of mulch. Writing our equation, we can say that x is soil. So we have the 3x applies to the soil. And then we have the 10 bags of y mulch is going to equal the total cost. Now, going to part B, if Josh spent $40.91 in total and mulch costed $2.75 per bag, how much was each bag of soil? Substituting each thing that we know, 3 times x, we don't know the soil price, plus 10 bags of mulch costing $2.75 per bag is going to equal the total cost spent, which is $40.91. Try then solving for x, see what you get. You should have gotten the amount per bag of soil to be $4.47. All right, let's move on to another part. Talking about scatter plots now. Scatter plots used a lot in science, we use a lot of math too. They show the relationship or correlation between 2 types of variables. You can have a positive correlation, meaning that the trend of the dots go upwards. A negative correlation, meaning the trend of the dots go down from left to right. Or no correlation at all, meaning there is no pattern. It's kind of randomness as to where the dots fall. Now the line of best fit right here kind of is a prediction line of the trend that the data is going in. And we can make an equation to find the trend of where the graph is going to go, and that's what we're going to do in this part of the video here. This first example, we're going to make a scatter plot, and then we're going to show the line of best fit and also kind of come up with our line of best fit equation. Try making the graph right now. I'm also going to show you how to do this on the calculator as well. Don't forget to label your axes and scale appropriately. The scaling that I came up with, I labeled the D in depth on the x-axis, going from 0, counting by ones, all the way to 16. And then for T, temperature in degrees Fahrenheit, I started at 70 and went up by ones all the way up to 85. Now I'm going to plot my dots on the scatter plot. And I have a negative correlation. It's pretty clear. I'm going to now come up with a line of best fit. I'm going to do this on the calculator and show you the more exact way on how to come up with your line of best fit, other than just taking your pencil and kind of guessing where the best estimate of the points are. That would be a good guess. Let's actually do this on the calculator and see how close we are. Calculator, what I'm going to do is press, and the directions are at the bottom of this page. You're going to press stat and then enter. I have a table. L1 is where the D values will go. So we got 0, enter, 4, enter, 7, enter, 10, enter, 12, enter, 15, enter. Pressing the right arrow to get to L2, that's where the temperature values will go, 85, 82, 81, 79, 77, and 76. Make sure that you have the same amount in L1 that you do in L2, same data values. Next, you're going to press stat again, then you're going to go over to calculate, and we are going to calculate lin reg, that means line of best fit. Pressing enter, Pressing enter again, we get our A and B values. In this case, A and B stand for your slope and y-intercept respectively. So we're going to write y equals, instead of A, we're going to write our negative 0.606, and then x, and my y-intercept looks like it's 84, so plus 84.853. That is my line of best fit. Looking back at the graph, I had my y-intercept at 85, pretty close, and I had a negative slope. In this case, my slope is a negative 0.606. Now to answer our final question, we're going to do some prediction questions after we come up with our line of best fit. So we're going to predict the temperature of the lake at 25 feet, taking 25 and thinking about what variable it stands for. 25 is the depth. That's going to stand for D, and we're going to figure out the temperature. In this case, D stands for the X value. So I'm going to plug it in, and for X, negative 0.606 times 25 plus 84.853. That will give you the temperature. I got about the temperature equaling 69.7 degrees Fahrenheit, which, looking back at the graph, if the graph did continue all the way to 25, it would go below the 70 here and about 69.7 degrees Fahrenheit. One more thing I just want to quickly touch on before we end the video. Go to the back of this page real quick. I have examples involving year. This first example here started the years at 0, 3, 6, 9, 12, in years since 2000. Be careful with that. In number 3, it starts the year instead of 0, 3, 6, 9. It starts actually at 1985. I strongly recommend crossing these out and always starting years at 0. So this would be years since 1985. So 1991 would be 6 years since. 1993 would be 8 years, and then so on. This is 11 years after, and then this would be 13, and then 2001 would be 16. Just a little detail that I would encourage you to remember in terms of years. Write down whatever questions you guys have for today, and have a great night.